So is relationship A a function? No, it's not. And I'll tell you why. When x equals 3, this is right under relationship A. When x equals 3, well, when you look at your graph, when x equals 3, y equals 1, 2, 3, 4. That's the ordered pair 3, 4. Or y equals 1, 2, 3, negative 4. So if you have an input of x equals 3, you actually get the ordered pair 3, 4 or 3, negative 4. This is not a function. Not a function. Now I'm going to do the same thing. I'm going to do the same thing for this next graph, which is relation B. Can someone tell me what kind of graph that is? That graph has a special name. You learned it at some point in your math career. Begins with a P. Sounds kind of like Ebola. Parabola, yeah. This is a parabola. Do you guys remember that? It comes from, so this relationship B, when I go to x equals 3, 1, 2, 3, and I draw my vertical line at x equals 3, how many times do I touch the graph? Yeah, I only touch it one time. I only touch it one time. So when x equals 3, I get the ordered pair 3, comma, negative 2. That's where that point is. So this one is a function. This action that we're doing is called the vertical line test, okay? So just remember, it can only touch the graph one time. It can only touch one time. So it says, explain which of these relationships is a function and why. Well, I'm going to use that definition exactly. The vertical line test shows that the relation B is a function because I'm going to abbreviate B/C. The line touches the graph only once. And I know that's a lot. I'm going to make it kind of nice and big and freeze that so you guys can see it. Why is it a function? Well, it's a function if the vertical line only touches the graph one time. If it touches it more than once, it's not a function. So I'm going to use that definition of it touches it only once. It touches it only once. So because this is a review lesson, I'm going to try to cram as many things into your brain that you know as possible. Okay, so like I tried to include as many definitions or vocabulary terms in there to just refresh you of things that you know. Are you guys good with this? Does anyone need it for more time? I got you. Cool. Are you doing okay? I do. Cool. Yes, good. Halfway? Halfway all the way. Halfway? Good deal. Are we good? So let's look at this next example. Example number 2. Okay. So this function right here, this function y equals x squared minus 1 has a special name. You guys learned about this in Math 1. Do you guys remember what this is called? It makes a parabola graph. Yeah, it's called a quadratic. And it's called a quadratic because it is a degree 2 polynomial. Now, I know these are things that you maybe forgot, but you've heard them before. So it's a quadratic because it's degree 2. When I say the word degree 2, what do you think when you look at that function, y equals x squared minus 4x minus 1? Where do you think the degree 2 comes from? The exponent. Yeah, that degree 2 comes from the exponent on the leading coefficient. Okay. So this is a degree 2 because of this right here. If there was a 3 there, that would be a degree 3, and it would be called a cubic. If there was a 4 there, that would be degree 4, and it would be called a quartic. Okay. Those are things that you're going to do in math 3. You're not doing that in math 2, but I just want you to know where that came from. Okay. So this is a degree 2 polynomial, and we call degree 2 polynomials quadratics. So the first thing that I have to do is I have to state the function's y-intercept, and this is nice and bold because it's a vocabulary term. So I'm going to write out the standard form of a quadratic. Y equals ax squared plus bx plus c. That is the standard form of a quadratic, okay? And you learned that the y-intercept, does anyone remember what the y-intercept is in terms of that equation? It's what? Yeah. The y-intercept always equals c in the equation. So here, c is 1. Yes. The y-intercept equals c when it's written in standard form. Good job, you guys. How many of you said that? I heard like 3 or 4 of you. That's awesome. Good. Tell me what the y-intercept means in terms of a graph. Yeah, it's where the graph crosses the y-axis. If you don't need that as a reminder, you don't have to write it down. This is just a reminder, right? So if you know what the y-intercept is and you don't want to write that down, you don't have to. It's just kind of a reminder. So I want to look at this next question. It says, between what two consecutive integers does the larger x-intercept lie? So let's talk about what an x-intercept is. If the y-intercept is where I cross the y-axis, the x-intercept is where I cross the x-axis. And there's something special about the x-intercepts of a parabola. They have 3 different names. They sometimes are called the zeros of the function. Does anybody else remember a name that they have? Begins with an R. Say it. Oh, I thought I heard someone up there whisper it. No? You don't want to share? Okay. Sometimes they're called the roots of the function, and sometimes they're just called the solutions of the function. They all have the same meaning. The x-intercept is also called a zero, a root, or a solution. Well, that's pretty confusing. Why does one thing have 4 different names? I don't know. I think that that's ridiculous, but it does. So I'm going to look at this question that says, between what two consecutive integers does the larger x-intercept lie? So I'm going to use my red marker, and I'm going to show you, here's one x-intercept. That's where one point is that I cross the x-axis. And here's the other place where I cross the x-axis. I just want to know, what 2 numbers does the largest x-intercept fall in between? What 2 whole numbers does it fall in between? So first of all, tell me which x-intercept is larger, the one on the left or the one on the right? Yeah, the one on the right is larger. So let's think about what 2 numbers does that fall in between? Well, that's the number x is 1, 2, 3, and x is 4. So it lies between x equal 3 and x equal 4. That's just you kind of looking at a graph and being able to identify a root, an x-intercept, or a solution, and finding out what point it's at or where it lies, okay? Does that make sense? Okay. The next question says, hey, draw a horizontal line at y equals -2. And it just so happens that the equation to a horizontal line is y equals a number. So I'm going to draw a horizontal line at y equals -2. So here's my horizontal line. Okay. It says using the two graphs. Did everybody draw that horizontal line? Do you see that that line crosses your parabola? How many times? Yeah, it touches the parabola 2 times. Here and here, right? So it says use the two graphs to find all x values that solve the equation below. And the equation below is x squared minus 4x plus 1 equals -2. Where did that equation come from? Well, this is the quadratic, and this is the linear, right? One is a quadratic function and one is a linear. And we set them equal to each other. And when we do that, we find out what points make it true. That's what it's asking you. When you set those equal to each other, you find out what points or what numbers, what x values make the equation true. So what are the x values that make this equation true? What does x equal at each one of those points where they intersect? That's what it's asking you. Any ideas? Well, when x is whatever this is, I cross both lines. And when x is whatever this value is, I cross both lines. So what are the two x values that work for both equations? Go ahead, Zach. Yeah, when x equals 1 and when x equals 3. That's a lot of stuff in 2 little pages or 1 little page. That's a lot of information. Okay. I'm going to ask you a question. We're really not talking a whole lot about graphs today. We'll do that tomorrow. But if I were to draw an arrow right here, can someone tell me what that point is on your parabola? Huh? What's it called for a bonus point? It is called the turning point, David. It's got another name, but that's good. I'm going to give you that bonus point. +1. Who else? Someone other than David. It's got another name. Good job, turning point. Come on. Huh? You forgot? Begins with the letter V. Vertex. Raise your hand if you said that. 1, 2, 3. Okay, so Aiden, Carter. Carter, you're on the back page. +1. Zach, you said it, right? Zach. Corey, yes, said it. Did anyone else say vertex? Am I missing someone? Okay, good job. Yeah, it's the vertex or the turning point. Very cool. We'll talk about more of that tomorrow. Okay, flip over to the next page. Okay, so we're going to use our graphing calculator because sometimes you guys brain dump and you forget all about your graphing calculator. So everybody has a calculator on their desk. Every day your seat number and your calculator match, right? And that's where you're going to keep your calculators. So consider the linear function f of x equals 1/2 x plus 2. I know this will be the last thing that we do because I see what time it is. So do the following by using your graphing calculator's table. So how do I put this function into my calculator? How do I do this? Yeah, I want everyone to go to the y equals on their calculator. the y equals button. Okay. So you're going to go to your y equals, pick up your little calculator. You might have to clear out the equation that's in there. And remember that f of x is the same thing as y. You're not typing that. The y is already there for you. How do I show 1/2 in my calculator? Mathematically. Yeah, 1 divided by 2. So I'm going to type in 1. Hit the division button. 2. X. Where do I find the X button? Does everyone know where to find X on their calculator? Yeah, it's right below the link button. It's that first. It says link above it. It's X, T, theta. Press that button in. That's your X plus 2. And it says go to the table. So now I need to go to the table. How do I get to the table? Yeah, second and graph. That will take you to the table. So after you do that, I want everyone to go to second graph. And if anyone has any crazy numbers, like my graph is starting at 2000, my table is starting at 2000. That's just because I did that myself. So it's asking us to evaluate the function at f of -6. What the heck does that even mean? Who said they don't know? Colt, that was you that said you don't know. True? Yes, it was. It was. Did you put in your function in your... So put your table really fast. Table set and make it start at 0. And then go second graph. That's right. Okay, so find -6 on your y values. It means when you let x equal -6, what's your y value? -1. When x equals -6, when x equals -6, y equals -1. That's the order pair -6, -1. That's what that means. Okay. What about f of 0? It's just saying, hey, let x equal 0. That's the order pair 0, comma what? 2. What about f of 8? When x is 8, what is y? Say it again. 6. That's the order pair 8, comma 6. Okay. If you can't find that on your calculator, raise your hand so I can come and show you. You don't know what page we're on?
It wasn't just the next page.
Oh, you know what?
Yeah, we do. We do have that.
It's in there. That's fine. That's fine. We'll start on the next page tomorrow. Okay. I want you to have a good day. No homework tonight. No homework tonight. Have a great day. And I will see you tomorrow. Will, don't forget your Chromebook.
Rose, how was your winter break?
Hey, Will, you touch my screen where it says stop share, that blue button up there.